Assalamualaikum. Today we want to present Workshop Technology Chapter 2 Drilling. Course Learning Outcome CLO1 Apply the knowledge of basic mechanical components and equipment, hand tools and measuring equipment in workshop technology. We are from Group 3 consisting of Muhammad Amirul Aiman bin Muhammad Tarmizi, Muhammad Adib Adwa bin Muhammad Nazri, Muhammad Faris bin Cik Jihari, Muhammad Adi Irfan bin Adi Rizmal, Muhammad Najib bin Ahmad Razwan dan yang terakhir Muhammad Imran bin Muhammad Razak. Topic of the day is Spindle Speed Revolution RPM and the feed rate, including factors that influence the selection of the cutting speed.
Calculate spindle speed revolution. RPM, speed of spindle in revolution per minute, RPM, or N. Rate rotation of spindle is based on size of drill bit. If drill bit smaller, then RPM more higher. Importance of measuring speed of spindle. Determine type of material. Identify speed cutting of material. Center line drill bit.
Calculate spindle speed revolution. Measure RPM. So how to measure RPM is RPM equal to cutting speed meter per minute divide by multiple center line. And then convert unit to mm. So RPM equal cutting speed multiple 1000 divide x multiple d. So cutting speed increase. Carbon steel to the high speed steel and carbide. Calculate spindle speed revolution RPM. Exercise 1. Calculate spindle speed in RPM for the hole with center line 35 mm on aluminum surface with cutting speed 35 meter per minute. Using heavy duty drill bit, RPM equal 227.33, approximately equal to 228. So cutting speed V equal to pi multiple D multiple S divided 1000. Spindle speed S equal to V divided pi divide D multiple 100. So then RPM 25 multiple 100 divided 3.142 or pi multiple with 35. So okay.
Standard Spindle Speed Revolution. Lihat jadual di bawah. Feed rate. Feed rate increase as drill size increase. To cause chip cutting edge. To light chattering noise. Dull cutting edge. Boleh lihat jadual di sebelah kanan. Feed rate formula of main spindle. Calculate the spindle speed if feet per revolution 1350 mm, spindle is 270 mm.
Factor in selecting the cutting speed: diameter and material of cutting tool, type of material being cut, material of workpiece, condition of drilling machine, distance point on circumference of drill will travel in 1 min.
Question 1. Name the part with the label A, B, C, D, E and F as shown in figure 1A. A. Fixed anvil. B is spindle. C is frame. D is leaf. E is thimble. F is ratchet. B1. Describe the term marking out. Marking out consists of transferring the dimension from the plan to the workpiece in preparation for the next step, machining or manufacture. 2. Explain 6 steps in marking out process before drilling. First one, mark the center hole with the center punch. Second, make 2 circles. First circle is for the hole. Second circle more smaller than the first one. Third, make the center of the hole again with center punch. Fourth, Turn on the machine and make sure the marking hole exactly on center hole. 5. Check either the drill rotating on concentric or not rotate. To check either the drill bit on the center hole or not. 6. If the cutting out of center hole, the hole diameter can be correct by making groove by using a round knife point. Third, identify 5 factors that should be considered in selecting spindle speed for drilling. Diameter. First one, diameter and material of cutting tool. Second, type of material being cut. Third, condition of drilling machine. Fourth, speed of twist drill referred to as cutting speed, surface and peripheral speed. Fifth, distance point on a second stem of drilling width travel in 1 minute. C. Calculate the cutting speed if the twist drill diameter is 18 mm and the rotation per minute is 993. 993 equal to cutting speed times 1000 divided by pi multiplied by 18 millimeters.
Now we look at paper 6, question 1. A1. State the vernier caliper reading below. How to read vernier caliper? First, you have to find the mean scale and vernier scale. The reading on mean scale is 3.1 mm and reading on vernier scale is 0.75 mm. So we have to plus the reading on mean scale plus reading on vernier caliper. Mean scale is 3.1 mm and vernier scale is 0.5 mm. A2. State 4 types of gauges in a medical engineering workshop. A. Vernier caliper. B. Micrometer. C. Steel ruler. D. Vernier angle trim. B1. State and explain 2 techniques in a filling process. Reading is one of the activities of leveling the surface of the workpiece to achieve a certain size, flatness, and smoothness by using a file made by hand. Grading would also require strong energy and must be diligent, tenacious, and thorough. Determining the basic field. What they mean by the basic field is the field that is used as the reference to taking measurement, elbow, and alignment to other field. A bend shape job must have at least 3 basic fields, where the basic fields are taken from fields that are adjacent to each other. B2. Clarify 5 approaches of file care. 1. Make sure the file has an appropriate handle. 2. Clean up pin and bow that embellish at file T or cuts. 3. Use the right file based on the workpiece material. File that has fine T or cut is used for handle material. Do not use file for other work than filling. 4. Use road grade file first of smooth grade file for finishing. 5. Use file cut to clean up the file. Avoid file from oil and water, as oil will cause the slippage during filling and water will cause corrosive.
C. It with twist drill diagram. Identify 5 main parts of it. 1. Drill head. 2. Column or pillar. 3. Adjustable table. 4. Spindle. And the last one, 5. Chuck. Thank you.